Today we're looking at acceleration due to gravity. A freefall type thing. We're using a ball bearing as our item that's falling. Traditional methods use a spring-loaded clip to release the ball bearing. Our old one had this device where you held the ball bearing on and then let it go, and it would break contact with these screws to start a timer. The old method we had what teachers refer to as a trapdoor, which is held shut by a magnet making contact, and when the ball hits it, it opens and breaks the contact, stopping the timer. And since I've been here, we've been using a slightly different system. We made an electromagnet to release the ball bearing to get a better start for the timer, and still use the trapdoor to stop the timer. However, having to build more sets and improve them, we've changed things a little bit. I've got trapdoors that have the little micro switch inside, which is there. You can hear it click when something hits the trapdoor. And because we were having, first of all, commercial electromagnets held on a rod, plastic rod, in a retort stand, and we can have an extension on the retort stand so you can adjust the height a bit further. And we were having trouble. We used to use a two-way switch to switch the power off to the electromagnets and a brake for the timer to start, but we're having trouble with the switches picking up something. They were starting the timer as you touched them. Very small drop in voltage was starting the timer. So we're now using these little units, which have a solenoid built in them, to switch the power to the solenoid off and start the timer when the ball bearing is released. So they have a 12-volt supply into them. Let's put the camera down, put this down so we can see the timer and the solenoid device. We plug the solenoid in this side. We plug the other solenoid terminal into the start gates of the timer. Oops. And our stop gate, which goes on the floor, into the common and the stop of the timer. So I've got the timer set to brake to start and brake to stop. I can power those up, switch the timer on, switch the solenoid on, switch that on, reset it. So put a light on there. When that's on, the solenoid is working. Now, the solenoids can get a bit hot, so try not to leave those on for too long. So when I switch this, the timer will start. The ball hits the gate, the trapdoor, it will stop. And from the distance between the bottom of the ball when it's attached to the solenoid and the bottom of the ball when it hits the gate, and the time, distance over time, we can work out the average speed, and it's going from rest, so from that we can work out the acceleration. So that's my setup. Bend down, pick the ball bearing up. We've even made the holders for the ball bearings when they're not in use by sticking a little cap onto the solenoid units. So these were made from a dry lining box for sort of a double socket, and this is plastic downpipe cut to shape and just bolted in a spacer on the micro switch, and holes through and bolts through for the hinge on the trapdoor. You can possibly see in there to see the switch inside. So we have to turn back on, and then we can reset, and we're ready to go again. Stick the ball on the solenoid, and when you flick the switch, it will drop. Timer starts and stops when the trapdoor is hit. And that's our version of G by freefall. Although I've been referring to this device as a solenoid, it's actually a relay which does contain a solenoid. So the switch switches the solenoid on and off, which switches the yellow sockets, which are where the electromagnet that holds the ball attaches, and it switches the green wires on and off, which are the start gate for or go to the start gate of the timer. So it is a relay, though I've been referring to both that, the relay, and the yellow sockets that go to the electromagnet. I've been referring to that as a solenoid as well. So sorry about that.